6.1 Ratios, Proportions, and the Geometric Mean. In Unit 6, Similarity. If A and B are two numbers or quantities, then the ratio of A to B is actually the fraction A over B. The ratio of A to B can also be written as A colon B. For example, the ratio of a side length in triangle ABC to a side length in triangle DEF can be written as 2 to 1, or 2 over 1, or 2 colon 1. 2 colon 1. Ratios are usually expressed in simplest form. Two ratios that have the same simplified form are called equivalent ratios. The ratios 7 to 14 and 1 to 2 in the example below are considered equivalent. Let's think about the width of this rectangle, RSTU, and compare it to the length of the rectangle, RSTU. If we think about the ratio width over length, then we would have 7 feet over 14 feet, and 7 over 14 simplifies down to 1/2. Notice how when we write the ratio, we divide out the feet over feet, and we no longer have a unit of measurement on our ratio. Let's think about the ratio 64 meters to 6 meters, and the ratio 5 feet to 20 inches. We want to simplify the ratio. In the first example, we notice that both 64 and 6 are in meters, so we can simplify them as they are. But in B, we have 5 feet and 20 inches. So we're going to have to do a little extra work in that one to deal with the fact that they don't have the same unit of measurement. In part A, it'll be simple. We'll write it as a fraction and simplify. But in part B, we can't simplify ratios with unlike units, so we'll end up having to multiply by what's called a conversion factor. 64 over 6 in A, notice meters over meters simplify out. 64 over 6 simplifies to 32 over 3 because both 64 and 6 are divisible by 2. 64 divided by 2 is 32. 6 divided by 2 is 3. And so I end up with 32 to 3 as my ratio. But let's look at B, 5 feet to 20 inches. We're going to need to divide out feet and inches from this problem. So we need a conversion factor. We know that there are 12 inches in 1 foot. So we're going to multiply by 12 inches over 1 foot. Notice how I've got inches and inches, one on top, one on bottom. Feet and feet, one on top, one on bottom. That's what allows me to divide that out. Then I multiply straight across. 5 times 12 is 60. 20 times 1 is 20. And then I can simplify 60 over 20 as 3 over 1. Use the number line to find the ratio of the distances. We're looking for the ratio of BE to CE. Remember that we can actually find the length of BE by counting from 2 to 10, or simply by subtracting 10 minus 2. I'm going to use the subtraction method. The length of BE is 10 minus 2, which is 8. The length of CE is 10 minus 4, which is 6. All I have to do now is write my ratio and simplify. BE to CE would be 8 over 6, which simplifies to 4/3. Therefore, the ratio of the distances would be 4:3. An equation that states two ratios are equal is called a proportion. Sometimes you will see these referred to as extremes and means, as you can see in the diagram. I'm often not going to use those terms, but I wanted you to see them. In order to solve a proportion, we'll use the cross product property. That's maybe the butterfly method that you've heard in the past, which says if I multiply the extremes and I multiply the means, I should get the same value. 3 times 4 is 12. 2 times 6 is 12. And because these are equivalent, I know these two proportions are equal to each other. Let's use the cross product property to solve some proportions. Let's look at A. 5 over 10 is equal to x over 16. The first thing you're going to do is determine your means and your extremes. Then multiply. In this case, 5 times 16 is equal to 10 times x, using the cross product property. That's going to give you 80 is equal to 10x. And then just divide to get x is equal to 8. If you have addition anywhere in your fraction or subtraction anywhere in your fraction, you're going to need one extra step. So let's look at B. Look at the y plus 1. We're going to need a little something extra to deal with the fact that there's a plus in one of the pieces of the fraction. Locating our means and extremes, we're going to see that it's 1 times 3y is equal to 2 times y plus 1. If you wrote y plus 1 times 2, that's okay. Then go ahead and multiply. And here's where we add a step. We need distributive property here. 1 times 3y, that's just 3y. But we need to multiply 2 times y to get 2y, and 2 times 1 to get 2. Now we can finish up this problem. Subtract 2y from each side, and we get y is equal to 2. As part of an environmental study, you need to estimate the number of trees on a 150-acre area. You count 270 trees in a 2-acre area, and you notice that the trees seem to be evenly distributed. Estimate the total number of trees. This is a real-life situation where you don't want to have to walk a 150-acre area and try to count all the trees on 150 acres. That's a tremendous amount of distance and the number of trees to try to count. What you can do, though, is pick a much smaller area, assume the trees are going to be about the same all over, and use your smaller area to determine your larger area. So where do you begin? Well, you're going to write and then solve a proportion involving two ratios that compare the number of trees with the area of the land. So what does that look like? Okay, well, we know that for 270 trees, it was 2 acres of area. You're going to set that equal to, let's say, n for a number of trees over 150 acres of area. Just make sure that if you start with trees in the first fraction on top, your second fraction also has trees on top. And if you have acres in the bottom, stick with acres in the bottom. From here, just solve cross product, multiplying 270 times 150 and setting that equal to 2 times n. And then just a quick solve, just multiply and divide. You're going to get that n has to be 20,250. What does that answer mean? That answer means that there's about 20,250 trees in that 150-acre area. See, told you didn't want to walk around and count. Let's look at one more thing, the geometric mean. The geometric mean of two positive numbers A and B is the positive number x that satisfies the proportions a over x is equal to x over b, so that x squared is equal to ab, and x is equal to the square root of a times b. Let's watch a short video on that. That seems complicated.
All right, in this video, I just want to do a quick little example about the geometric mean, and also to point out, what kind of how you can think about it, what it means. So the definition, the geometric mean of two numbers, A and B, what we do is we multiply those two numbers together, and then we take the square root of them, and that's the geometric mean. So certainly not the same as the arithmetic mean, the average. I think that's the one most of us are certainly more familiar with. So let's look at a simple example here. Let's find the geometric mean of 4 and 9. So again, what we'll do is we'll multiply those two numbers together, and then we'll simply take the square root of those. So 4 times 9, well, that's going to give us 36. So we have to take the square root of 36. Well, that's simply equal to 6. So we would say that the geometric mean of the numbers 4 and 9, the geometric mean is going to equal 6. So, what's special about the geometric mean? I guess, again, I think an average, an arithmetic mean, it's kind of the middle point, right? And I think, people, you find an arithmetic mean if you want to find, for example, your average grade on 2 tests. So, what does this number 6 represent in relation to 4 and 9? Well, what it has to do with ratios. Okay, so we started with 4 and 9. Those were the numbers that we were finding the geometric mean of, and we found that geometric mean to equal 6. Well, notice if we look at the ratio 4 divided by 6, and then if we look at the ratio 6 divided by 9, well, 4 over 6 reduces to 2/3. Hey, 6 over 9 also reduces to 2/3. So this is kind of what's special about this number, the geometric mean. If you take the ratio of the small number to the geometric mean, and then if you look at the ratio of the geometric mean to the larger number, those ratios or those fractions are going to be the same. Okay, so that's how you can kind of think about the geometric mean. Somehow it's giving equal ratios of those two values. So again, the arithmetic mean is the one that I think most of us.
Okay, so let's see if we can find the geometric mean between 24 and 48. So it's pretty simple. All you have to do is first determine what are the two numbers, A and B. Well, here we go, 24, 48. They're given. So just plug those in. Then go ahead and multiply 24 times 48, or look for a perfect square. Look for two numbers that multiply together that are the same number. So 24 times 48 could actually be written as 24 times 24 times 2. And the square root of 24 times 24, that's just 24. It's okay if you've forgotten how to simplify square roots like this, because really you can just find a decimal. So the geometric mean of 24 and 48 is 24 times the square root of 2, or you can just give the answer as 33.9. Okay, guys, time to practice. When you finish practicing, there is an assignment on It's Learning. Good luck, and I hope this helped.